Good afternoon and welcome to the 2022 last lecture. I'm so excited to see all of you here. My name is Nicola Corbin and I'm the director of the Teaching and Learning Forum. And at the Teaching and Learning Forum, we aim to support our faculty as they cultivate their passions and their talents. They grow their passions and their talents and they flourish. And speaking of flourishing, we're here to celebrate and recognize an exceptional member of not only our Weber State community, but also our Ogden community, clearly by the diverse sets of folks who are here. So without further ado, I won't take up any time. I would like to invite Dr. Colin Inglefield, who is the chair of the Department of Physics and Astronomy, to introduce our guest of honor. Thank you.
Hi everyone, I'm Colin. And yeah, as Nicola said, I'm currently chair of the Department of Physics and Astronomy. I came here in 1998. So John was already here when I came, and of course I'll be forever grateful for his help in getting me started, getting my lab set up, teaching me how to manage my time and mentor students and all of that. Recently, though, we've had a different relationship because I'm chair, so every year he comes to me and I have to evaluate his annual report at the end of the year, and I think those conversations always go about the same way. I sit down there and I read through it and I say, that's a lot. That's a lot. But anyway, today's job is perfect for my skill set because I'm introducing someone who doesn't need an introduction. I'm sure we all know John because he's helped us understand something that's hard to understand, or helped us get some piece of equipment working in our lab or our cars or whatever, or maybe even rescued us after a bad decision, whether that was on a Tuesday at work or on a Saturday in the mountains. So as I think about the department, if someone were to carve a Mount Rushmore of Weber State physics and astronomy, putting aside the question of why anybody would ever do that, John would be on that. And I think he would be our Teddy Roosevelt. And mostly because of the glasses. But more than that, they also both took expeditions in the Amazon. But beyond that, it's because John, like Teddy Roosevelt, was a doer. Somebody who does things. That person, Teddy Roosevelt, said, far and away, the best prize that life has to offer is the chance to work hard at work worth doing. And I think that fits John, because we all know if he finds a thing that he thinks is worth doing, whether that's search and rescue, or science fair, teaching students about the universe, mentoring students in the research lab, he will devote an enormous amount of his energy, intellect, passion, and just time to those things. He's a doer. And I'll just stop there because if I'm not mistaken, I think John is going to talk to us today about some work worth doing. So I'll turn it over. John Sohl, Brady Distinguished Professor of Physics and Astronomy.
Well, thank thank you very much, Colin. I really, really appreciate that. Okay, so thank you for attending the last lecture. So far, you've already been participating a little bit. Let me plug in. The audio visual in this room is a little different than pretty much any other AV setup on the entire campus. So the only way I can switch between sources is by plugging them in. So hang on. It takes about 6 seconds. I timed it. All right, so 70 of you have already made a vote. And so there's your vote for what's your favorite season. It looks like we have a strong preference for autumn. Good thing, because you're in it. So at least you're in a happy spot in your year. Here. And so let me see if this will reach over here without creating a disaster. There we go. And see, it's right here. So it's time for the second question in this sequence. So pull your phone back out. This time I'm going to let you see the scores appear as they appear. So this is going to be another easy one. The very next question after this is not going to be so easy. Alrighty. So this is actually good. This is perfectly fine. Every one of these activities will allow you to do what I'm going to be talking about here coming up before too long. So anyway, those were the easy questions. Let's go ahead and jump forward to the harder questions. And so we'll leave this as it is for the moment. Let me escape out of it, and you'll be into a new screen now. All right. So let's go ahead and step forward. Oh, there we go. Sweet. Oh. No. All right, there we go. So I want to first start out with a little discussion about how we got to this spot here, and then we're going to jump right into the main topic. But I want to answer the question. So that's the fourth point down. What can we do? What can you do? What can you do to save the planet? The answer is nothing. At this point, we're just host. So that was the last lecture, everyone. Over there. And actually, that is the correct answer, but that isn't the only answer. And so we're going to look at some other answers to this question as well as we get going along here. All right, so let's first of all, I want to start out, the Teaching and Learning Forum has been on campus here at Weber State for at least 20 years or more, 25 years. It's got quite the history, and they have supported doing quality education for that entire time. They're a huge asset, and I want to say thank you very much to the staff of the Teaching and Learning Forum, not just simply Dr. Corbin, but all the staff for the stuff that they do quietly in the background. They arrange quite a few things on campus for those of you who are faculty to help support what you do. I also want to talk a little bit about Weber State. So Weber State is an interesting place. Why did I pick Weber? I had several job offers when I chose to pick this one, and curiously enough, I didn't apply for any jobs in Kansas. I only looked for places with mountains, and so it fit the mountains category, so I checked that one off. Fit a variety of other things: good skiing, good rock climbing, good colleagues, interesting university. Actually, it wasn't; it was a college. And so when I started, it was Weber State College. Yeah, it's been that long. And it had an interesting challenge. The challenge was that, unlike the other places that I got offers from, this one had a planetarium, and they were looking for somebody to run the planetarium. And I had never run a planetarium before. I thought, that sounds curious. Going to give me a chance to work with kids, and it could be kind of fun. It's a little different. So more than a third of my time here, I was the director of the planetarium, and had a great time running that for 13 years. It's very, very rewarding to me to see that each subsequent planetarium director has expanded it even more and done better stuff. And so that program has just really done well, and I'm really pleased to be a small part of that. But that was one of the things that brought me to Weber State. A couple of other things brought me to Weber State and then kept me here. One of the things I promised to myself when I started, because I left industry and took a substantial pay cut to come here, but thought I'd give it a try and figured I'd see if academia and education was a fun thing to do. And so I promised myself each year I'm going to reassess and decide, do I want to do another year or do I want to go back to industry? Because I had fun in industry too, that was an enjoyable job. And I've stayed here for 33 years now. Why stay here at Weber? So Weber has never really said no to any of my crazy ideas. And so, for example, I have to admit, I probably didn't always ask. So one reason that you don't get a no is by just simply doing it, not bothering to get permission. And so I suspect that nobody in the administration knows that Brian Cox, the British dude that you've probably seen him maybe on BBC, Brian Cox and I got together to do a BBC special, and so this is, there's a bunch of Harvard students, my research team, out on the Bonneville Salt Flats with helicopters and BBC camera crews and stuff like that out there. And the fact that we've got helicopters flying over our students, like literally 50 feet above them, I'm not talking about way up, and that we're busy putting them out in places where Brian Cox almost passed out from heat. And he's from England, right, so he wasn't ready for it. So anyway, the fact that nobody ever said no, or hey, we need a contract for that, it's a lot easier if you just don't tell them that you need a contract for that. So that was kind of what I did most of the time. But most importantly, these students in this picture, and some of the students in this picture, it's a set of pictures, are a set of students with a wide bit of diversity to them. Some of these students are students that have been given up on by other universities. Students who failed out of a university then came here, or maybe failed out of 2 universities and then came here. And here they thrived. When those students came here, students that are in this program, including a few students I know that had literally failed out of another university, came here and did well, and then went on for other careers where they became industry leaders. There are quite a few people in Northrop Grumman now, in any engineering company in northern Utah. You just say Northrop Grumman, you got about an 80% chance of being right. And so, they are leaders, middle management, upper management in technology and aerospace. And students who've gone on and gotten PhDs and are now working at national laboratories. I can think of 2 in particular that are doing work for our nation. Started out here as failures, and they had been rejected by others. But Weber State gave that nurturing environment that allowed the faculty to work closely with the students to develop those people's potential into what it can be. That's why I stayed at Weber State, because Weber State provides this opportunity and this ability to find the diamonds in the rough and really allow them to expand. And for that, I really appreciate this university, and I stayed each year because it was fun to do so, and because I had quality students to work with and fantastic faculty to back me up, and administrators that either didn't know enough to say no, or were willing to let me go through, or in some cases would back me up at the last minute. I'm sure the people in the Office of Sponsored Projects, whenever they see an email from me, they first go and get a cup of coffee before they open it up, knowing that it's going to be some last minute thing. But I appreciate that support that I've gotten from all levels of administration at this university. And that makes this place special. All right, so real quick, just a smidgen about me. So ultimately, this is your chance to slip out. The downside is you'll miss the snacks. You can probably grab something on the way, though. Anyway, I've been doing atmospheric science as my primary research for about a decade and a half now. And something that I noticed about 4 or 5 years ago was a fundamental change in our atmosphere. We have been doing lots and lots of flights to the very edge of space. We take packages and students build sensors. We fly these sensors to literally the edge of space. We are above 99.6% of our atmosphere, which is a smidgen above us. We are in conditions comparable to the surface of Mars. And then these things parachute down 70, 80 miles downrange, if we're lucky 10, and then we go and recover them and bring them back. And we've gotten very familiar with how things move through the atmosphere and how things move through the jet stream. And about 3 or 4 years ago, maybe 5, something changed. Something fundamentally became different. Our flights were more unstable, our flights ran longer, our flights were unstable for longer periods of time. If we had bad flight predictions in the past, we could wait 2 days, maybe a day, and then we'd have a good flight. Now we have to wait 5 days, 7 days, maybe 10 days, and then we can get a good flight. Something changed in our atmosphere. We hit a threshold of some sort. I have some ideas what it is, and I've been arguing with other colleagues about it, but there's been a threshold of some sort, and we sensed it with our Weber State students going out and flying packages through our air. So I've spent a lot of time thinking about our atmosphere and doing various other work for quite a long time. And I've spent a fair bit of time outside looking at things. I'll show you a couple of pictures here. There's at least 2 people in this room I think are in some of these pictures coming up. When I was a kid, we had oil being shipped by tankers, still today, of course. At that time, tankers were all single wall. And if the tanker hit something, or if something failed, you would get oil spills. We had oil spills all the time. And as a child, at say 10 years old, when you are handed a oil-soaked plover, you don't think of birds as having much in the way of facial expression, right? It's a beak, it's a couple of eyeballs. They don't even have eyebrows, right? I mean, it's just not fair. And so birds can't smile, they can't frown. But when you would look at this bird, it was desperate. And it was looking at you of like, save me. It was desperate. And to hold a bird that's literally dripping oil is an incredibly heart-wrenching thing to do. And I did that as a child. And I started to develop my awareness of the universe around me and of the environment around me. And of course, this is a time of Rachel Carson's novel, book, Silent Spring. It was just coming out of the market. Very, very important. And so it was a period of time when we were seeing some serious problems. Rivers were catching fire in Ohio, you name it. So during this period of time, we as a people, you, stood up and said, no, no. You stood up and said, we are going to insist that you do double-hulled ships, and we're going to make you do it. And I don't care that it's expensive. And we as a people required that. What that did is that made the companies change their mentality to, okay, we'll have to do that, from the earlier mentality is, oh, that's just lost product. That's what they consider an oil spill. An oil spill is lost product. But we as a group changed it. We can do hard things. We need to keep doing that. That's the sort of stuff we have to do. This is my mother in 1965. She's protesting the siting of an incinerator for garbage. And they put a big burn plant right next to an elementary school, literally 100 meters away from an elementary school. And they fought it, and they lost. So it's still there, it's there. Today the elementary school's there, it's still spewing out, heavens knows what. But it was at least worth the fight. By the way, reading this really, really closely, I looked down here, and I hadn't actually ever noticed this before, but the city councilman that they tried to contact for comment, his first name is Ogden. I guess I kind of came full circle in something like that. So anyway, I take some pride in being miserable to people in office for quite a long time. So I've spent a lot of time outdoors. perhaps too much. And this is located on the Eklutna Glacier in Alaska. Let's see, I think Jared was there. I forget, were you there? Anyway, that's me. That's a guy from Korea. That's a guy from Austria. This is 200 feet down inside of a crevasse. And being inside of a crevasse is an interesting experience. On one hand, it feels like an ice cathedral. On the other hand, it feels like an icy grave. And it's a very, very odd place to be. And you can tell that I'm actually not a particularly brave person. Because if you look closely, right there, I was frightened enough to stick an ice screw in. Even though I've got 2 ropes going to awesome anchor systems, I still stuck an ice screw in. Because I really, really didn't want to go any further down into that crevasse. And so what I was doing while I was waiting for the people to practice, I was busy taking ice balls and chucking them. And I would time them. And I would time how long it took to hit the bottom, and I would use that to then calculate the depth. And so I figured that I was about another 200 feet to the bottom, and so 200 feet down. So this crevasse is about 400 feet deep. And if you've ever been in a crevasse, it's an interesting experience. I encourage it. It's make sure you've got good ropes. The conditions here were modest. Driving rain, 100-mile-an-hour winds, 80-mile-per-hour constant gusts to 100. And so it was actually kind of nice to be in the crevasse. But in any event, the fact is that I've been to some of these places, and then as little as 12 years later, Sherry, my wife, and our son Ian went to see some of these glaciers, and we couldn't find them. There's this one spot we were trying to kayak up to, and I'm thinking, it's right here. I checked the map probably 10 times. I was like, no, this is where it was. This was an awesome glacier. Turned out it was another half mile around the bend and back up into the ravine before we found the face of the glacier. It was like 12 years that glacier was gone. And that same problem is happening throughout the planet. This is in the Alps this past August. Our glaciers are in such desperate situations that we're literally putting tarps on the remaining little bits to try and keep them intact. Oh my gosh, there's no 200-foot crevasse in this thing. And so this is where we've come to. We've made some serious mistakes. All right, so here's your next task. Okay, so go ahead and get started up here. You're not going to be able to do anything until I start it. Okay, there you go. So I'm not going to let you see what the result is just yet. So go ahead and put that in. You're going to, every 2 of these things, you have to put in a new code. Sorry about that. So go ahead and put that code in here. Feel free to talk with your neighbors. This is the most difficult question that we're going to look at. And so we're going to take a few minutes on this one. So chat with your neighbors and decide how you want to do this. It's going to be hard. We've got 9 items, and you've got 100 points. Rate where you want to put those, where you think is the most urgent places to put our efforts in these 9 items. If you think something's more important than something else, you have to start scavenging points. Now, 100 points to work with, 9 items. You can put 99 points on one of them, and then 0 for everything else, and 1 for another one if you want, or you can make it all about 11. So one of the hardest things about moving forward is deciding where to move forward and what to address. After we get a few more, I'll share the results with you. It is very hard. I told you it was going to be challenging. Okay, the last one had 74 votes. We're only a quarter of the way there. Actually, a little more than that. Okay, you can see how they're starting to come out now. So we got 62 of you, so that's the vast majority of you. Until just a moment ago, it turned out that disinformation, misinformation was leading. And I will not disagree with any result that you come up with, because all of these are urgent issues for the future of our planet. Alrighty, so as it turns out, it's appropriate for this talk that climate change is winning, because that's what I'm going to be talking about. But I claim that many of these things are intertwined. An awful lot of what drives climate change is being driven by disinformation, and that then becomes misinformation. Disinformation is information that is fabricated on purpose to mislead you. Misinformation is information that's spread because people honestly believe what the information was and are passing it on. And it's just simply not true. So that's misinformation as opposed to disinformation. So anyway, turns out that climate change is of course going to be affecting water issues and access, and associated with climate change, the main cause is pollution. In particular, of course, carbon dioxide pollution, but also pollution in the form of methane. Methane is in many respects much, much worse. It just doesn't stay in the atmosphere as long. Carbon dioxide that was released by Leonardo da Vinci by burning a heating fire in the hearth in the house in which he was imprisoned for the end of his life. That carbon dioxide is still in our atmosphere, a substantial fraction of it. Centuries later, 4 centuries later, some of the carbon dioxide from Leonardo da Vinci's fireplace is still in the air and we still breathe it in. It's that persistent. And of course, poor governance is a big issue here in many, many ways. Turns out that authoritarians are not so concerned about the climate and climate change. If you want to be able to make a dent on climate change, you had better have a functioning democracy, because non-functioning democracies don't care. And so you could argue that that's the most important issue there, because unless that's in place, none of the rest is going to happen. You can make that argument for almost every one of these positions here. All right, let's go for one more question on this one. And I'll leave it up this time. Let you see what other people are doing as you put yours in. So that means the first voters are going to be the brave ones. A slightly different take on the same question.
So appropriate on election day.
We're going to come back to that. So the statement was, it's so appropriate for election day, and yes, it is. I have to admit, I did not think ahead when I chose this date. It was the date that fit my calendar, but it couldn't have been a better date. All right, so as the votes come in, I'm going to be collecting this data, by the way. It's completely anonymous. I have no idea who did what, but I'm going to save the information. So as it turns out, all of those things are intertwined. It doesn't do you any good to have a functioning economy if the planet collapses. What's the point? And it doesn't do you any good to have have global security when there's nothing worth being secure for. And by the same token, climate change, one of the greatest voices to fight climate change in our government has been the U.S. military. The U.S. military is extremely concerned about climate change. Why is that? They're extremely concerned because climate change drives immigration, it drives economic collapse, it drives people who are desperate, that are trying to come across borders, it drives all sorts of aspects to our global security. And so you can argue that that is the driver of global security, not the other way around. And so all of these things interface with each other. If your economy is collapsing because your environment is collapsing, The collapsing economy is what causes crime. So all of these issues are completely intertwined with each other. Let's go ahead and go back to our other slide here. Let me escape from that. All right, so moving on from this one. So climate is what wins on this thing, no doubt about it. So let's go ahead and do a really, really rapid, I'm going to take the assumption that nobody in this room came here thinking, oh, what's climate change? And so with that as a basic understanding, we're going to march through a real quick review of a little bit of issues on climate change. So I've got a map here that's kind of fun. It has on the top, oh, that's the name. Oh, that's not bad. On the top here, it has kind of a graphic of what was going on at that point in time. Everything from modern day stuff to and so the scale here is kind of funny. So this sort of funny scale that we've got going here breaks in different sort of time frames. You've got really short time frame here, and then this is in millions of years down here. For that. So this is a plot of two things. It's a plot of temperature, in one case based on data collected by multiple different ways of measuring the temperature, using tree rings, using bubbles from glacial ice, all sorts of different methods, and then weighting them with our levels of confidence to come up with our best possible value. As of this date today, this is the most current, best information that we have right now. And that is superimposed with this black line here with the dots on it, which is our models calculating what the results would have been purely by our understanding of the environment. That's a pretty good match. We're doing pretty good here. We've got a good handle on what our environment's doing. So it's interesting to take a look at this line right here. This red line is the line at what the temperature is today, as opposed to what the temperature has been over millions and millions of years in Earth's history. And you'll notice in that you have to go back a pretty long ways here to get to a spot where it is reliably warmer than when it is today. Let's step into that just a little closer here. So this is looking at a slightly shorter period of time. This is looking at the period of time of Homo erectus. And so this is the period of time in which humans that you would recognize, and if you took Neanderthal and put Neanderthal in a suit or in a good business attire, gave him a good razor, or at least trimmed him up some, you wouldn't recognize Neanderthal from somebody else. They were that close to us. And so anyway, this would be the time of Homo erectus over this period of time here. The area that I have circled is over the box that is cleverly listed as behavioral modernity. What does that mean? Behavioral modernity is that region at which we started to develop a language. Not language that we could just get simple ideas across. The great apes, birds, a lot of your dog, they're all capable of getting basic ideas across. But I'm talking about being able to get ideas across that are sophisticated. To be able to sit down and talk about, hey, how about them Mets? And so, really highbrow issues. So that's this period of time here. That's pretty interesting. Notice at that period of time there, somebody who you would be interested perhaps in sitting down and having a cup of tea with, no human in human history has ever lived on a planet as warm as ours is right now. No modern human has ever lived on a planet this warm. Let that sink in. We are on a different planet. Our planet is new for any human being that you would be able to relate to in all the time of modern behavioral humans. Let's take a little bit look at a closer time. So here is this is global temperatures. The area listed as the medieval warm period and the little ice age, those were for Europe. Clearly this was not a global phenomenon. To some extent the little ice age was some. But certainly the medieval warm period actually dropped a little bit. And so this is European temperatures. So for a little bit of scale here, so right at the beginning of this, on the far left side, that's the time of Christ. And then right around about 300 or so was when Christianity started to become adopted in Europe. And so in the year 301 was when Armenia was the first nation in Europe to make Christianity the state religion. And right around about here, at around 560, or 570 I mean, is when Muhammad was born, and that was the birth of Islam. For what it's worth, the Judean faith was well off to the left there, so when it started. But our modern version of the Judaic faith started probably in the vicinity of 1,000 or so, depending on who you believe or count or where you decide to start counting, but ballparkish 1,000 BCE. And so we continue on. So here's Muhammad coming in here. And right around about 1400 or so is at the beginning of the medieval warm period there. That's when Leonardo da Vinci was dissecting humans and making the first anatomy books that we still use today to some extent. And then as we continue along, around 1600 is when Galileo brought out his telescope and started observing the world and became the father of modern science and defined how we do science, that we make experiments and we observe the universe and then we make hypotheses and we modify those. That's how we define science. And that was done in 1600. 1608 was when he came out with some of his publications. And so that was way up to here. It wasn't until around the 1800s that we came out with the periodic table of the elements. And then we get into 1900 or so, right in the middle of those guys, we're starting to go up a little bit. That's when Albert Einstein proposed special relativity. Finally getting up the curve here a little bit, we get to Stephen Hawking. And so Stephen Hawking was around about this sort of time frame here. And things are shooting up. So any kind of culture, at least a Western culture, I've noticed I've ignored Chinese culture, Indian culture, and that's because I'm figuring that most of the people in this room have come from a European background, so I deliberately stiffed them just to kind of match the audience. But they had a similar audience, a similar development of their cultural background as well. So our culture that we can really relate to, you would have a hard time really getting along immediately with somebody from the Renaissance. Or even worse, from somebody during the medieval period of time when Europe collectively turned their brains off. It's only in this time frame here that are people who would understand or be able to understand your car and how that works, and it's not magic. And so from here, all of that history from the times of Christ through Islam and all the way up until pretty modern times, our temperatures wandered a little bit, and then we found oil. Oh my gosh. There's a reason that we call one of those brands Quaker, because it came from Pennsylvania. And then that didn't really kick it off, though. It really got kicked off in 1901 with Texas. And we got black gold, and that really started us off to the races. And boy, we were good. We used this stuff with incredible enthusiasm. So let's continue on from there. So very quickly, there is indeed a connection between global temperature, CO2, and sea level. All those things match each other pretty darn well. We are able to trace a lot of these things back way, way further than what I've done here. And this is only going back 400,000 years. I chose this because it covers about half of this is modern modernity, behavioral modernity. Alrighty. So you might ask, well, surely there are Milankovitch cycles and other sorts of complicated things you've heard about, but you have no idea what they are. And so all these various things happening, climate changes all the time. Cool. Well, let's take a look at that. We have a pretty good understanding. So this is the sun's energy, the sun's output here. Notice it's got little humps. If you look at those humps carefully, you'll see that there's an 11-year period there. Welcome to Astronomy 1040. And so that's our solar cycle right there. Every 11 years we get lots of sunspots, not very many, lots of sunspots. And so that doesn't seem to be driving it, the sun being more active, less active. And then when we look at things like CO2 and look at the just base cores to see what the CO2 is for longer times, that is a pretty good match there. So. All right, well, what about other things? It's not just simply the sun. We've got other things that drive our, climate's been changing since the dinosaurs and before the dinosaurs. Well, okay, we can do that. We can take a look at what would happen if we removed humans. So this is the natural forcers right here, and then this is the result of the of putting in human impact. And then the black line here is what we actually see is the temperatures coming out on our planet. And we can see that the natural forcers aren't up to the job. They're just not getting it done. So thank heavens we've stepped in to really drive this thing right. Okay, so this is from the IPCC. This is sort of the most commonly accepted standard. It's the most conservative and carefully thought out committee. This is an international group of scientists to get together to determine the status of our climate and our atmosphere. And so there's some good news in here and there's some bad news in here. So these different results that are coming up here are coming from different models. These models up here with these kind of odd names of, SSPS-8.5. What that basically means is this means business as usual, coming up here in the red, and then the green over here means that we're trying really hard to reduce our emissions on these things. So here's the good news. The good news is the red is never going to happen. The red's not going to happen. We are not going to increase our temperatures from 14, which is where we're at a long time ago, to these global average temperatures in the 19 and 20 range. We're not going to increase by 5 degrees C. Isn't going to happen. It's not going to happen for a variety of reasons. First of all, coal mines and coal power plants are getting old. As they get old, they have to be phased out. It is just simply cheaper to build renewable plants than it is to build another coal plant. Coal mines are being shut. Now, unfortunately, we're replacing many of them with natural gas. And so we could be doing better, but we are getting rid of coal. Natural gas is a little bit better. So we're making headway there. So that's never going to happen. And that's great. Here's the bad news. So there's two bits of bad news in here. Let me go ahead and go to the next slide here. So notice that even the optimistic, let's really get on this right now, still is going to go up some. There's inertia here. This is a train that's going to take time to stop. That's why we need to start now. And so we're still going to be increasing by 0.7 degrees. Well, we've already gone up by 0.88 degrees, depending upon where you do your counting from. And so you'll see different numbers. That's because some people say, well, 0.88 from the 1900s, early 1900s. From some people say from 1950, or maybe from 1980, or maybe from 2000. So wherever you set your base point, I'm going to choose to set a base point back in the early 1900s. And so that puts us at 0.88 degrees above where we were then. And we're almost double that. The best that we can do, we're going to nearly double that change, even if we all jumped on it today. So that's alarming. The other alarming thing is that any of these values here, even though we're never going to hit this top one, even these values here, it's actually worse than we thought it was going to be. So where we thought the level of water issues were going to be, where we thought the level of coastal communities having troubles with storm surges, wherever we thought the intensity of hurricanes was going to be, it's actually higher. And so even though we're not going to hit that high limit, that limit we're looking at is very, very severe and a very concerning level. All right, so one fair question is do we believe these predictions? Are we any good at it? Yeah, we're actually pretty good at it. So this is some data that was done a while back. They actually did the analysis about here, but this is taking data that we already knew and using the predictions for those. And then this was predicting forward and then coming back afterwards and seeing how well we did once we had the future option of hindsight. We did pretty good. So our ability to predict what's going to happen this is actually pretty high confidence. So we can do this. This is good, because if we understand the problem, we can address it. All right. So, no big deal. All these predictions are, in 2030, it's going to be this temperature. In 2050, it's going to be this temperature. In 2100, it's going to be this temperature. Well, I don't know about you, but I'm planning on being around in 2050. I'm gunning for 95 or 100, and that's going to have me around in 2050. And so I'm concerned about 2050. And even more importantly, my child is concerned about 2050 because he's definitely going to be around. And that's what really gets me. And the other thing that gets me is I have an incredibly big family. I have literally thousands of children. I'm really good at that. Anyway. That's all my students. So as my students have come through my classrooms, I've gotten to know them, I've worked with them in my research groups, they become my concerns as well. And I want them to have a good future. If I didn't, I'd have gone back to industry and made more money. And so my interest in staying as an educator is because I really like my students. And I want my students to have a future. If I didn't want them to have a future, why was I doing this job? And so, yeah, that's a ways out. So we have a couple of solutions here. So let's take a look at this car here. So we've got two approaches. Which one's cheaper? So I have one method where I can be driving my car and I can go, oh, there's flashing lights up ahead. There's a bunch of car stuff. I see a lot of brake lights. I better start easing off and starting to get myself ready for this. So that's one approach you can take. The other approach you can take is, oh, I see flashing lights up ahead. I see a whole lot of brake lights. Cool, I got like 10 seconds. Awesome. All right, 5 seconds. We got this. 2 seconds. Yeah. Slam on the brakes, come screeching in. Yes, in for the win. We stopped literally 30 centimeters from the car in front of us. We could have gotten closer, but we did. So those are your two approaches to driving your car. You can anticipate ahead and drive casually and anticipate what's going to happen, or you can just come in there full stop, let's go for this, and we're going to screech into it and just do the real Hunter Thompson thing. And so squealing. All right, so which of those is going to be more expensive to your car over time? It's pretty obvious, right? You're going to have to be replacing tires and brakes and all sorts of damage. Your suspension's going to be wearing out sooner. All that kind of stuff is a problem. Well, the climate's the same thing. If we wait, it's going to be more expensive. If we start now, it's going to be wicked expensive. But if we don't start now, wicked expensive isn't even beginning to touch it. It's going to be more and more difficult to do the longer we drag our feet. And so that's why we've got to act today. Okay, so tipping points and climate thresholds. I mentioned at the very beginning of this that we had seen a tipping point and something had changed in our atmosphere. We want to avoid tipping points because tipping points are a serious problem. Think of this rubber band. I can stretch this rubber band, no problem. And it has a certain amount of elasticity to it. It can respond to that. I can do things that are egregious to it, and it will recover from that without any kind of a problem. But on the other hand, if I'm too egregious, and I really pull on this thing, uh-oh, it snaps. And as soon as I reach that threshold of strength, and it can no longer handle it, at that point it fails. Are we in terrible condition? No, we can fix this. We can tie a knot in there, and we can fix this rubber band. Now, we could try and glue it together. Maybe an overlapping joint would be better. Now, is it going to be the same? Is it ever going to be as strong again? Of course not. And so once we reached that point where it was fundamentally different, it became a problem. We want to avoid those. In atmospheric science, we refer to these as thresholds. In common lingo, they're often called tipping points. And those tipping points can be something as simple as taking a glass, I can pour water into it, life is good, no problem. I can keep pouring water into it. And finally, at some point in time, I've reached a problem. I've reached a threshold. And when I've reached that threshold, at that point in time, I've now made a system that is fundamentally unchangeable from where I was before. I can't easily get that back in there and return the system to where it was. And so the point is we need to act before we hit too many tipping points. Okay, so really fast, what kind of tipping points are we facing? So I'm just going to hit a few of these things. So you've got Arctic ice melting off. As soon as we lose too much of the Arctic ice, the sun will start to get absorbed by the oceans faster, and that's a serious problem. We have the Greenland ice sheet, we've got the West Antarctic ice sheet, we've got the East Antarctic ice sheet, we've got the ice sheets that are sitting on top in glacial valleys. We have changes in the rainforests, the boreal rainforest and the Amazon rainforest. We have happening in Africa and India, the monsoons are changing. We have changes in the coral reefs around our planet. We have a lot of serious problems that are facing us. There's one that I find most frightening. The one that I find most frightening is not a global heating. It's not a problem with too much temperature, too little temperature. And that's a spot right there. That's an interesting spot right there. That spot right there, when you look at global maps, you've all seen these things in the news where they're showing the planet's warming, and they show you all these red things and stuff like that, showing where it's warmer from before. Look at the North Atlantic. There's always a blue spot up there. That blue spot is frightening. If that blue spot gets a little too big and a little too strong, that can shut off a huge ocean current. This ocean current, the part of it that you're most familiar with is called the Gulf Stream. The Gulf Stream is not just simply the Gulf Stream and going up the eastern seaboard. That is a global conveyor belt that goes throughout the oceans of the planet, where it is transferring massive amounts of energy to equalize and drive climates and stuff like that around our planet. There's a reason, if you ever look at a map of Europe and the United States, it's crazy if you think about it. Europe is like way up near Santa's house, whereas the United States is way down. We don't need Santa. We need tropical clothing in comparison. And so it's funny to look at the latitudes of where Europe is. Europe is remarkably high. Why can Europe have the environment that they have? Why can they have the culture developing there that they have? It's because the Gulf Stream is pumping warmth up there and is allowing Europe to have the weather that it does. And of course that makes London a pretty bad place to be if you don't like fog. If you don't like rain, well, don't go to London. But that all happens because of the Gulf Stream. And the Gulf Stream dives down here and moves energy around the entire planet. If that gets shut off, that's a tipping point that we will never be able to recover from in any kind of format that you would recognize as a society compared to today's. There will be a dramatic change to our planet. If you want to talk about refugees and stuff like that, oh my gosh. If that happens, it will be serious. So anyway, those are the tipping points I'm concerned about. All right, so as it says there, that hottest summer we just had, 53,000 people died in Europe just this past summer. Those were what are called excess deaths compared to normal. And that's because it was pretty hot there. Well, in 15 years, that's going to be an average temperature. So kind of put some of this urgency in position here. All right, so time again. So let's do this. The questions get easier. So your code there is at the bottom. All right, that's it. I think we can see the general trend here. Thank you very much. Okay, here's another one for you. more votes come in. All right, so here's the great news. The great news is we can do all these things. Every one of these is an option that's available to us. Okay, let's come back to our other slides here. Kind of a weird way to shift back and forth. There we go. All right, so today's election day. Far and away, the most important thing you can do is carefully look through the candidates and figure out which one of these people cares about your future, not their own power, not their own money, not their own prestige, but you and your life, your future existence. Those are the people you want to vote for. Those are the people who are going to make a change. I like this slide a lot. This was at a local protest that was being done here in Ogden for the Youth Climate March back in 2019. And Sherry took this shot and called my attention to this image. And I think it's a fabulous poster. So we really need to jump in ourselves. It's time for us to take some action. All right, so the most effective thing you can do, run for national office. So, Green New Deal, rather than attacking her, let's take and find out where the weaknesses are and start someplace. Yeah, it's not good. The Green New Deal is going to be hard. And it's not perfect. There's a lot of flaws in it. But we've got to start somewhere. And if we start with something, that's something, maybe you have a better something. If you have a better something, great, propose it. Let's get it moving forward. But attacking the Green New Deal is not good. If you're going to attack it, propose something else at the same time. Not all of us can make Emmy Award-winning movies, 2 of them, about climate change and try to work to change that. Not too many of you are going to think about Richard Milhouse Nixon as being the great environmentalist, and you'd be right, he's not. However, and this is important, Nixon put through an enormous number of incredibly important environmental issues. The Clean Air Act, the EPA, all sorts of different things all happened with Richard Nixon. Some of those actually got vetoed and were overridden by Congress and still moved forward anyway. But the point is, he supported most of them. Why did he support those? He supported them because he wanted the young vote. And in particular, he wanted the young vote because something else was happening that time that I personally was facing. I was facing the opportunity for an all-expenses-paid trip for a vacation to Southeast Asia. And I was not happy about it. And there were a lot of people not happy about that. And so, fortunately for me, I just missed by a few months. But the fact of the matter is there were a lot of unhappy people about Vietnam. And Nixon wanted their votes. It was votes that made Nixon change and support all these things. Votes are what matter. You can make a difference. You can push these people in this direction. All right, so fine. We can't all be Al Gores or Greta's. So what can we do? Well, the first thing is you can vote like your life depends on it, because it does, at all levels. When you vote at the local level for somebody who supports green spaces and water conservation, that's going to make a dent. And that information helps support and feeds it up to the people at the top. Likewise, the people at the top put in policies that feed down. You've got to do it at both ends. Pester these people. And so I have to admit, the last year or so, I've been with COVID and all that stuff, I've kind of slacked off. But there was a point in time, pre-COVID, where at least one of our representatives, I got to know some of their staff members. I called them enough times. And so I called them up and talked to them. It's actually better if you call than if you write yet one more email or yet one more postcard or something like that. Call them up. Your local representatives, they'll answer the phone. I remember the first time I called up Pritchard. Oh, I expected to get a staff person. Oh, it's you. Oh, okay, great. Well, let me carry to you. So call these people up. The simple fact of the matter is that you've got to let your voice be known. And then the other thing you can do is you can pass this information on and the urgency for action to everybody that you know and start to make a dent in that direction. So what else can you do on a personal level? Well, here is, this is a massive research project that was done to figure out what personal actions could be done to fight climate change. Notice that there's one giant elephant in the room there. So I'm going to show you this graph on a slightly different scale after a little bit. But far and away, if you are an American, the best thing you can do for the environment is to have one fewer children. Nobody's saying don't have a family. Nobody's saying don't have whatever number of kids you're going to end up with. We're just simply saying have one less. And support those people who did decide to stop a little earlier than they were thinking of. And help enrich their lives and help support them against the people who are tearing into them. Aren't you having more kids? Be on their side. Help support that. Okay, so let's take a look at population. So this was from yesterday. Turns out that we add a new person to the United States every 44 seconds. We have added about 40 people since I started this talk. And the world population clock is going up even faster. You can actually watch that roll as when you click on the link there, if you do that link there. So we've got a pretty good sized population. Let's hop through a couple of slides here. This is global population. Fun thing about an exponential graph is it looks this way no matter where you look at it. But the simple fact of the matter is that this is where we're looking at it now. This is the United States population. Here, it's not my coloration. I'm not the one that said this is red. That's from the U.S. Census Bureau. So let's take a look at that scale a little bit differently. And I've given you this graph. I'm going to give you a QR code at the very end of this, not too many minutes from now, that you can download this graph and a whole bunch of things where I give you ideas of what you can do personally to make a difference. And I give you some references and stuff, and even I give you a few fun YouTube videos to look at. What can you do? Well, you can live car-free. That's pretty hard in the United States. And what these bars are for, these bars are the average for developed nations. The little bars are what it is for that individual country. Notice that for the United States, not having another child makes a huge difference. Notice that there's a chop in the axis here. And then these various other ones on this extended axis, you can now see them. All those LED light bulbs you installed, good on you. That's great. I'm glad you're doing that. But it's not going to have much of an impact in the end. That's not where you want to put your efforts, although it's good. We've done that in our house. So living car-free in the United States is very hard to do. But you can at least reduce the number of cars. One of the things that keeps getting it on the chin here is airline flights. People are really making the airline industry the bad boy in climate change. It's like, oh gosh, the last thing you should ever do is get on an airplane. It's terrible, terrible, terrible. I think that's wrong. I think that's wrong for a couple of reasons. The most important thing is, if you want to have empathy for the rest of the world, if you want to be able to understand how other people live and appreciate different cultures, be there. Go to those cultures. Spend time in these other places. Explore other parts of our planet and appreciate the fabulous diversity in our globe. And the best way to do that is to go there. But here's what you can do. Do a little less often. Or more importantly, what I would prefer to say, in this do it less, one light less, is from the research paper. But if you instead don't go to Europe for 5 days, for 7 days, go to Europe for 2 weeks. Go there for 3 weeks. Your job will survive. The United States vacation system is stupid. It just is. You need to do what the Europeans do. Take a month off. And when you go there, you've already made your carbon impact to get there. Once you're there, that carbon's in the atmosphere now. If you're going to just then immediately fly back, that's nutso. Stay there, spend some time. You're not adding to the carbon footprint anymore, and you're expanding your knowledge of other people, and hopefully are being a good ambassador for what we are. That's what I would recommend that you do. Get to know other people to build empathy for the rest of our planet. I'll let you look at the rest of this slide in the handout. All right, so we've got one last thing to do here. Let me bring it up. right, we got quite a few. Okay, I'm going to admonish you real quick. This bottom one, that's one where you need to put your effort to. You need to get those people knowing what it is that you're thinking about. Give them a call. Move this forward. What's holding you back? At the moment, the only thing holding you back from snacks is me. So we've got about 2 more slides or 3 slides. Alrighty, so none of those answers is wrong, and you can participate at any level that you want as you drive forward on this. So let's go ahead and wrap it up here. And again, if you want to keep voting, that's fine. I'm going to keep that data, because I'm curious myself. Alright, so personal action, what you can do, whether it's on a big scale or a small scale, is worth doing. If you don't, the results are going to be disastrous. If you do, they may still be disastrous, but they'll be less so. You've got to move forward. We know we can do this. We can do hard things. We stop the ozone layer from deteriorating and it's starting to heal. We no longer have lead in our air and soil and water because we got rid of leaded gasoline. And we fought the powers that didn't want that. We no longer have as many oil spills as we used to have because we got together and we stopped that. You can get together and stop that too. We can change this. We can do this. We can make personal actions that will matter. This is in your control. The first thing you want to do is get out there and vote, vote, vote. And tell people what to do. Call these people. Make yourself a pest. Encourage other people to do the same sort of thing and to follow your example. You've got to be careful of disinformation. So as part of going out there and talking to people, there are several things that you want to be careful not to do. The first thing is don't repeat the misinformation. If you do that, that just is one more repetition that sticks in somebody's head. When they say something, I'm going to do this, I'm going to do what I just told you not to do. Stop the steal, the election was stolen. If you say that, and they say, no, it wasn't, the first words out of your mouth were reinforcing the misconception. Then you started to describe why that wasn't true. Don't do that. Just immediately start out and say, actually, the 2022 election, or 2020 election, was the most secure and least fraudulent election in American history as far as we know. And give straight information without repeating the misinformation. So I'll leave you there with a few ideas about how to deal with that. And like I said, there's going to be some more in the handout here at the end. So does it matter? And the answer is yes. You can be the virus. You can be the contagion that changes the planet by being an example, by talking to others, by showing people that you can do small things, you can do big things. The number of items that you can do are pretty large, and I've given you a much larger list in the handout that I'm going to give you before. I'm going to give you a handout in a few minutes. One of the things I want to state is this very last item. All right, I'm an old white guy. That's the demographic I am. I'm an old white guy. And here's what we've proven. We have proven that the old white guys can't do this. We're the ones that got us in this problem. It's just the reality of it. It's not shaming. That's just the reality of it. We're the ones that caused the problem. And it doesn't look like we're going to be able to solve it either. This is a problem where we need all brains on deck. We need everybody participating in this. We need women participating in this. We need people of color. We need people who come from underrepresented areas, people who are poor. All these people need to be brought up to speed and help work towards this goal. This is a goal we have to do as an entire planet. We can't discard half or 2/3 or 3/4 of our intellectual capital. All of that has to be honored, and we have to listen to their different points of view. The current points of view haven't worked. We need new ideas. We need to open up to other people and to what they have to say. All right. That QR code there has a handout with four pages of action items, of links to fun YouTube videos, of some statistics like that one big table from that publication and the link to that publication are all on that QR code. So at that point, I'm done. Any questions?